Hello, welcome to Astronautics for Exploit. This is Dr. Ayeshola Ogundele. Lunar Microgrid, a necessity for future manned lunar bases and missions. The focus points of my presentation are as follows. Microgrid, lunar power need, lunar microgrids, and lunar microgrids concept. On the Earth, microgrid, a group of interconnected loads and distributed energy resources that acts as a single controllable entity with respect to the grid and that can connect and disconnect from the grid to operate in grid connected or island mode is becoming very popular based on its advantages such as reduction in energy loss through transmission lines, high resilience to extreme weather conditions, easy management of power supply and demand, and enablement of zero emissions energy sources. On the Moon, due to microgrid's ability to operate independently and collaboratively with other small power grids, the lunar microgrid concept is being planned and designed for the provision of electrical energy and powering of the future moon bases and villages. Also, hybrid microgrid, which can be integrated with the main power grid, is being proposed. Lunar microgrids, also known as remote microgrids, that are detached from the main utility grid, have been identified as good sources of power for moon infrastructure. Various space agencies and private space companies are looking at ways to deploy microgrids in space. For example, NASA is working on installing microgrid on a lunar base, which will be responsible for the electrification of the Artemis lunar base using distributed energy resources such as energy generation, battery storage, and system parts that can be interchanged. The microgrid is also aimed at ensuring that the lunar base is online every time and power is available for normal day-to-day operations, nighttime operations, and emergency operations. Some of the lunar microgrid concepts being proposed are lunar grid, intelligent lunar microgrid concept, and flexible energy distribution between multiple micropower grids. Microgrid. Microgrids, self-sufficient energy systems, are localized grids that can disconnect from the traditional grid so as to operate autonomously. They can serve a discrete geographic footprint, for example, a university campus, hospital complex, business center, or neighborhood. In microgrids, there are one or more distributed energy, solar panels, wind tunnels, combined heat and power generators that produce each power. The picture here shows functionality of remote microgrids in harsh environment. Microgrid has various advantages, and it is being able to operate when the main grid is down. As a result, microgrids can strengthen grid resilience and help to mitigate grid disturbances, as well as function as a grid resource for faster system response and recovery. Many newer microgrids contain energy storage, typically from batteries. Some also now have electric vehicle charging stations. The picture here shows future diagram of a microgrid and conventional utility power grid. Flexible and efficient electric grid. Microgrids support a flexible and efficient electric grid by enabling the integration of growing deployments of distributed energy resources, such as renewables like solar. The use of local resources of energy to serve local loads helps reduce energy losses in transmission and distribution, further increasing efficiency of the electric delivery system. The picture here shows composition of a microgrid. A microgrid is defined by three key characteristics, such as the local, independent, and intelligent. It has a different form, such as campus environment, institutional microgrids, community microgrids, remote off-grid microgrids, and military-based microgrids. A microgrid is capable of operating in grid-connected and standalone modes and of handling the transition between the two. The picture here shows illustration of a microgrid. Lunar power need. Power is of utmost importance in achieving sustainable lunar presence and establishment of lunar city or village. The electrical power at the lunar surface must be reliable and available at all times for there to be a successful mission. The picture here shows illustration of NASA astronauts on the lunar South Pole. There are various reasons for power at the moon, and some of them are as follows: propellant manufacturing, manufacturing of tools and equipment using in situ resources or resources from the Earth, crew support and operations, scientific research and development, technology development and demonstration, and development of strategy for the deep space exploration, such as the mission to the Mars. An illustration of the gateways, power and propulsion element and habitation and logistics outposts in orbit around the moon is shown in this picture. New research findings show that moon dust can be used to create oxygen, hydrogen, and rocket fuels, which could help power human exploration to Mars and beyond. To achieve this, power is needed. Lunar power is also needed to fuel landers for round trips between the lunar surface and gateway, mining, excavation of regolith, and in-situ resource utilization. Artist's concept of the deployment of solar arrays on the moon for the conversion of sunlight into electricity on an initial lunar camp of the future is shown in this picture. Lunar microgrids. Lunar microgrid is a small-scale power grid designed for the moon that can operate independently or collaboratively with other small power grids. Lunar microgrid is planned to be supported by the renewable solar energy resources. Artist's impression of a moon-based concept is shown in this picture. Presently, there is an ongoing effort to design and demonstrate feasibility of lunar microgrid for the provision of electrical power on the moon. Different energy sources, storage methodologies, and continuous availabilities of the lunar microgrids are being considered. The picture here shows illustration of the moon habitat grouped together on the rim of a lunar crater known as the Moon Village. Power option. A lunar high-voltage microgrid with different sources of energy, such as solar energy, radioisotope, fuel cells, batteries, nuclear energy, and a host of others. Research is ongoing on the integration of different energy sources and electrical loads to meet the need of the lunar base or village. Concept of collecting solar power up in orbit is shown in this picture. Lunar microgrids concept. To have a continuous supply of energy on the moon requires a great effort to design, develop, and deploy lunar microgrid. Currently, various lunar microgrids concepts have been proposed. The picture here shows Moon Ranger, a suitcase-sized and autonomous rover headed for the exploration of the lunar South Pole. Lunar microgrids concept. Various concepts of lunar microgrids are being put forward, and some of them are Sandia National Laboratories microgrid designed for future lunar base, Astrobotics lunar grid, flexible energy distribution between multiple micropower grids, laser power beaming concepts, the tethered rovers that unspool superconducting wire into the crater, wireless mobile power beaming solution, and intelligence microgrid concept. The picture here shows illustration of celestial solar panels in space. Sandia National Laboratories microgrid designed for future lunar base. The microgrid concept is being designed as part of NASA's Artemis lunar base project, and the findings are expected to provide inputs to the control and resilience of microgrids on the Earth. To produce a lunar energy power management system that can efficiently maintain a level system on all the time scales is the design goal of Sandia Lunar Microgrid. Sandia National Laboratory's Lunar Microgrid concept is shown in this picture. Sandia 2 Lunar Microgrid design. Sandia is focusing on the design of the electrical system controller for the mining and processing center's microgrid, as well as that of a controller to connect the two microgrids, which is emphasized in cases of emergency to maintain resiliency and robustness. There are two primary ways to get resiliency in a microgrid. One is to have the ability to flexibly route power where it's needed. The other is to oversize everything to ensure there's enough power, even if multiple things fail. The picture here shows Lunar Survey's solar power concept. Astrobotics Lunar Grid. Astrobotic is designing lunar grid that will deliver power to customers at the south pole of the moon. The lunar grid will make use of the Astrobotics landers, rovers, and wireless chargers, as well as its vertical solar array technology, which is presently under development at Astrobotic Company. The picture here shows Astrobotic's lunar grid, which is being planned to use vertical solar arrays and rovers to deliver power to customers at the south pole of the moon. The power will be generated by vertical array technology, solar arrays that are deployed vertically and are optimized for operations at the lunar poles, where the sun is always low on the horizon. Lunar grid power distribution. The power distribution is designed to be from the vertical solar array technology to user through tethered rovers based on the Astrobotic's Cube rover design. The picture here shows Astrobotic Lunar Lander, Graven Lunar Lander, which is being planned to deliver a rover to the surface of the moon in the late 2023 to prospect for water, ice that could support future human missions. Wireless charging technology will transfer the power from the rover to the customer service asset. The system will start off generating about 10 kilowatts of power and can be scaled up at any time. The vertical solar array technology will themselves be mounted on rovers and can move as needed. Astrobotic initial customers for the lunar grid is NASA and Artemis partners so as to support their lunar exploration plans. The picture here shows Astrobotic lunar grid concept. SkyCorp Lunar Microgrid. SkyCorp is working on the design of delivering power to an oxygen-producing plant outside the moon crater. It is developing an innovative system of power cells and intelligent interfaces for storing and distributing power through the lunar moon's extreme light and temperature changes. The picture here shows rendering of a kilopower reactor on the moon. You've been watching and listening to Lunar Microgrid, a necessity for future manned lunar bases and missions, presented by Dr. Ayeshola Ogundele, Astronautics for Exploit. With the focus points microgrid, lunar power need, lunar microgrid, and lunar microgrid concept. Thank you.